Differentiation, functions of a function, chain rule derivation. If y equals sine of x, well, that meant y is a function of x. But if y equals sine of 2x minus 3, this time y is a function of 2x minus 3, which itself is a function of x. Therefore, y is a function of a function. And that's what we're looking at, function of a function, which means that you can also differentiate what's inside that function. So it itself is a function. In fact, that's a function, because if you differentiate that, you get 1. And that's why we don't look into that as a function. So really, everything is a function of a function. Right, so in this situation, what we will do is we say let u or v or t or whatever you like, let u equals 2x minus 3. And then we can say y equals sine u. Okay, so now we need to derive a function that would help us to be able to solve this. So this derivation is what we're going to do now. If we have a function, say we have fx, and then we change it by a little bit, and then we get f of x plus delta x, or you might say x plus h. That's what people do these days. So if this is x, and this will be x plus delta x, or x plus h. And if this is y, this will be y plus delta y, the small change that happens. And therefore, if we have u, that'd be u, this will be u plus delta u. So those are the small changes that takes place. For that reason, delta y over delta x for these changes, because we need that, don't we, will be equal to delta y over delta u times delta u over delta x. So now in the limit means that when it changes by a small finite value, we say delta x would tend to 0 because we want a very small change. Delta y will also tend to 0. Delta u would tend to 0. Therefore, we would have delta y over delta x will tend to the y over the x. Delta u over delta x will tend to the u over the x, and delta y over delta u will tend to the y over the u. So that's what all these threes are going to be applied. Instead of now using in the limit, we'll be using this. Therefore, we can say the y over the x equals the y. Therefore, we can say the y over the x equals the y over the u times the u over the x. If you notice that you can see if you cancel the u over the u, because they're on top of each other, the numerator and denominator, you get your dy dx back. Delta y over delta x, delta y over delta x. So there's no difference, it's the same thing. Again, if you cancel dy over the u, you get dy over the x back. So this is the new chain rule that we can use to solve function of a function. Now that's what we're going to use. Y equals sine 2x minus 3. We'd say let u equals 2x minus 3. Therefore, the u, the x, because u is a function of x now, will be, well, we know when we're doing differentiation, y has to be in the form of x to the power of n, and then we can say the y over the x equals n x to the power n minus 1. In this case, we have u equals x to the power of n. Therefore, the u, the x, equals n. So n here is 1. So 1 times 2 is 2. 1 minus 1. 1 minus 1 is 0. Now, x to the power 0 equals 1. Anything to the power 0 is 1. So that's why this is 1. If you differentiate a constant, you know constant has x to the power 0. 0 down will be 3 times 0, so that disappears. So that's what you get with du dx is 2. Now, we need to now write y equals sine of u. But what about the y, the u? If you differentiate sine, you get cos. So that will be cos of u. Now, finally, we need to then put these things here and use that formula. So therefore, we would say the y over the x equals the y over the u times the u over the x. So what is the y, the u? The y over the u is cos u times the u dx is 2. So that would be 2 cos u, which equals 2. We know what u is, cos 2x minus 3. So that is the y over the x.